Hello everybody, I will start my today's another coding practice. So this video is about this question. Swap adjacent in LR string. In a string composed of L, R, and X characters, like blah blah blah, a move consists of either replacing one occurrence of XL with LX or replacing one occurrence of RX with XR. Given the starting string, start and ending string result, return true if and only if there exists a sequence of moves to transform start to result. Okay, I see. So I will be given the string, which consists of only L, R, and X characters. And my task is to convert the given string start into the result string by replacing XL with LX or RX with XR. Okay. Yep. So I think for this question, everything is clear. Yeah. If the string is obviously empty, I can return, if the result is true. Sorry, if the result is an empty string, I will immediately return true. Yeah. And otherwise, always it will be false. And as a constraint, start ranks is equal to the result ranks. Yeah, okay. So the case I was telling, when start is empty, then I should immediately return true with this constraint. Okay. And aside from that, yeah, there's no, yeah. Okay, outstanding constraints. Okay, so let me think of this question with an algorithm as an example. So assume that the start string is this and end string is this. Result string is this. Okay. So when I take a look at this, first two strings, I should swap them. Yeah. Then after that, I will get this. And when I take a look at the second, XL here, it should be swapped. So I will swap it. Then it should be like this. And I will continue it. And swap this and this. Then I would say I can swap this and this. And in the end, I could create the result string. So I will return true. Okay. Yeah. So in this case, it was good that I could create the result string. And all I did was I firstly took a look at first two characters, then second another two characters, another two characters, another two characters. However, I think this isn't always the case. For example, say in this case, what I should do is firstly I swap these two these two characters, first two characters, and I will get XL, XXXX. Then next I will move that second L. So it should be, like this. And in that way, I will keep moving the, character L to the rightmost position. Yeah, or something like that. Okay. So that's the thing. So that being said, let me think of the operation itself. So what does XL to LX mean? Or what does XR to RX mean? So obviously, this suggests moving the L to the, oh, so wait a minute, XL with LX. Okay, so now I can say L is moved to the left, I mean, direction. And for this, R is moved to, sorry, RXXR. So R is going to the right direction. Yeah. So I can say, if I'm giving the string like this, moving R, so I can immediately say, this is not composable. I mean, creatable, generatable, because in the end, this R is at the left position of this original right R. So I cannot put R in the end without any operation. So that's something I found. So I can say, comparing start and result string, number one, each number XLR should be the same. Yeah. Also, every every R should be right hand side of R's in the start string. And for L's character, every L should be on the left hand side of those L's in the start string. So firstly, I can say these are the conditions which they have to meet. I mean, it has to meet. But also I can say, so okay. At least it has to meet this. Now I will think of condition 2. So in this case, even though L is at the left hand side and R is on the right hand side, it cannot be, LR is not creatable. Because I cannot swap LR. But if this is, LXR, LRX, so I think, no, this isn't still creatable, because when I swap X and R, it will be like this. And after that, I cannot move R to the right hand side or L to left hand side. So I'm thinking how I can filter this kind of situation and return false. So oh, I see. I can say any R and L cannot be swapped. So let me think. Think of this case. So in this case, I can see L and R are separated by X. I will take it in this way. And I can say this R can be any place which originally these four X's are by swapping. So I can create something like this. However, it cannot be, I mean, this R cannot go beyond this L. Okay, so that being said, I think I can greedy try to create an result string. So when I'm given this, Where is it? I don't know. Yeah. So if I find some string, what I can do is greedily try to create this string. So if I can swap this and this, I mean, if I should swap X and R here, I will. Yeah. So that's a greedy approach I'm thinking. But let me come back to line 34 and think of this a bit more deeper. So when R is here, I mean, so I can say the relative position of L and R doesn't change in the end. That being said, think of the case when the relative, order is the same and X are inserted in random way. And I always convert the first string to the second string, or maybe there are some cases that still I cannot create the result string from the start string. That's what I'm thinking right now. So I think it's always possible to create the result string in that condition, because I can move X to any place. So if I have this one, I can move X to any, distribution among R and L positions, separators. So think I'd like to move all of the X to the leftmost part. It's possible, because I just have to try to move, X to here and X to here. Then I find that this X should become here. Then I can move that X to here. Oh, wait, no, maybe not true. No, it's not possible. Because, sorry, X, when there is X on the, or I mean, if I were X, if I find L on the right hand side, they can be swappable. But L on the right hand side cannot be swappable. So if I'm given this, L can go to the left hand side of X. So this can be possible, this can be possible, this can be possible. And for R, it can go to the right hand side of X. So this can be possible, this can be possible. And again for R, it cannot be moved. For this L, this cannot be moved. So that being said, I will take a look at this string from leftmost, first character to to right forward. And if there is so if I find R, X can come before. And if I find L, X can move backward like this. And if I find R again, this X can move forward. Yeah. So they do. So I will use the 2 pointers probably. So that I can compare the start string and end string. And when I'm here and here, sorry. So this is R, so any X can come here. And this is X, so it can come here. Or if this is R, there is possible that take some X to this here position. So I think I will look forward from here, and if this is R, I will try to swap it with X here, because it should. And if also this is R, in this case, still I can move this X here. So say this is X, RRX to XRX is, sorry, like this. Still this is creatable, I think. Oh, sorry, let me just think of another case. So this is RRX, and if I get, yeah, in this case, it's still composable. Okay, so I think I come up with maybe possible solution. So for R, as I said, it cannot go, it can go right hand side, but it can't go left hand side anymore. So for every R, I will take a look at number of left hand side. So here, this is 0, 0, and this is X. And for this is left hand side, there are, what do you mean? So sorry, R can move right, and in that case, it will be something like this. So it's okay that there are so many elements in the right hand side, because as long as there is X, it can move backward. But if there are so many elements on the right hand side, they can't be swapped, so it's impossible. What do you mean? So okay, I see. So when I get this string, I can say this is R, which means that it can move rightward. This is possible. but it cannot go leftward. So there is a kind of, separator here. So everything on the left hand side should be formed into the result string, converted into the result string before this R, because wait, no. If this is R and this is R, then this X can go backward. So this can be XRR. So still this X can come here. Hmm. Okay, so okay, as I said, if there is R, R can go backward. So X can go forward. But X cannot go backward. No, sorry, R cannot go backward. Yeah. Hmm. Let me come back to here. If this is X, it cannot go. Wait, what was I saying? So if R and L's relative positions are the same, this can be swapped, so this can be creatable. However, this is not possible because no, it's possible, but I think so. I think this is not possible. Yeah. So this R can't go backward. Wait a minute. So maybe wait. Maybe I think I can use this and this. So in this case, so it doesn't work. Wait a minute. So what can I do? Let me think. I think I can simply use the greedy approach. So when I take a look at this, and if there's the same, it's okay. But if this is x, so it cannot be, cannot be. So I will try to move x from here. So I will take a look in this way. And if there is any r, I should swap it with the next element. So I mean, I have to find x until the next L. Because if there is L and if this is x, this x cannot come here. So it is impossible. So I have to somehow find x until next L. And if I find the x, no, R, no, sorry, x, then I will take it here by swapping. So let me think of this case. In this case, I find x here. So this should come here and here. I can swap them because until the first x, every character is R. So I can swap them. Then it will be like this. Then I move the pointer to the second. Then there's the same, so it's okay. Then I will move. So now this is R and this is L, so this is impossible to create. So let me think this is X. In this case, I have to find. Oh, so L cannot come to left. So at this moment, I can return false. So for L, they have to be the same as for the first try. But for R, we have the room to move the R from the. No, sorry, I was telling totally in a positive way with R and L. So if I find R, oh, no. Wait. So, okay, there are some cases. Expected is X and actual is L or R. Or expected is L and actual is X or L. So I have to think of these 6 cases, aside from the first match is the same. So let me try thinking again. I will think of these 6 cases. So in this case, I have to try to take X somewhere from here. And if there is L, it's the end. However, if there is many R's, it's okay, because X can come here. So this is okay, but this is not okay. Yeah. Then I will think of the second case. If there is L, so, and this is X, it can go left hand side. However, this cannot take any character later. This can be swapped by any character later, so this should be military X. No. And for XR, so I have to find R from somewhere later, but R can go only backward, so I can't take R here. Then next case, number 4, if L is here and R here, L will try to go left hand side, so this cannot be swapped anymore because characters before are already, checked, and they can't be swapped. And now for this, I will look for L here, and it is possible that if like this, it's possible to take L later. However, if there is any R here, R can, no, it's still possible. No, not possible. L cannot go beyond R, so this is not possible. So I can say if there is R, immediately it's the end of the check. Then, in the end, R and L, this is obviously impossible. Because for R and L positions can't be swapped. Okay, so that being said, let me do implementation with this idea. So let me say n is the length of each string, and I will take a look at each index. Then I will take a look at these cases. So if another case is start end is XL. In this case, it's still possible, but otherwise, I will return false immediately. Then in the end, I will try return true. Okay, so let me think for this case. If this is R and this is X, try to find any number, any character which is R. So and if I oh wait, so I will swap start string every time. Yeah. And if start no, sorry, I cannot mutate the string, so I have to say chars, and I will try to take a look at the chars. So every start has to be changed with chars. Okay, so in this way I can get the character at the, current string, which is under the updations. Okay. I will try to find R, but if this is L, I can immediately return false. Then, if chars J is R, I find this. I found the string, so I will swap chars I and J. then this is the end. And otherwise, I will try to keep, you know, now it's X. So what I should do is I can just, no, sorry. I'd like to find X. Okay. Sorry, so if in line 120, this should be in the case of X. So if there is X, I will swap it with, yeah. But I think, let me put R here, and let me move this one here. So in this way, if I find R, I can just ignore it and continue. Yeah. Because I'm looking for the next X. Yeah. So I will just skip that character and go to the next character. And if it is R, what happens is that it should be something like, sorry, this should be X. So this is the case. So I should swap char in position j, and I will get XRRR. And it's completely possible to create that because I can swap this and this, and then this is this in there. Yeah. So this is what I should do. And for the next case, oh, and I have to make sure that if I couldn't find X in the end, I have to return false. If I can't find it, I will return false. Yep. Then I will think of the other case when X and L. So I will do the same. So this is the case when something like this. So if I find R, that's the end. So I will immediately return false. And if I find X, then it's still possible that some L can come to the I position. I will continue. But if I find L, oh, I mean, in the end, if I find L, it should be something like this. So I should swap this I position, this J position. Yeah. And continue. Yeah. Okay. So I think this works. So let me execute my code. Is this? Okay, it's not accepted. So let me think. Expected true, but output false. So when this is LXXX, so firstly this is LXXX, and then it will change to seems like they swapped X and R. Then now it should be XRXX. So I is the current index where I should take a look. So here, when I get this, I will take a look index 1, so R and R. So they're the same. Oh, sorry. So if they're the same, I can immediately return continue. Yeah. So let me wait. Okay, good. So I will execute my code. Okay, now it's accepted. Okay, so the time complexity should be n squared because I can see there is a outer for loop and also there is an inner for loop. So at max, the inner for loop has to traverse almost all the remaining characters. So in that case, it should be, in total, it should take n step plus n minus 1 step plus n minus 2 step plus blah 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 plus 1, which is n squared time complexity. And for space complexity, I initiated the Charles list, which is the rank n. So that's the only extra space I need, which is not constant. So it should be O of n space. Okay. Oh. Why is this locked? Yeah, it's okay. I don't know. I have to subscribe it again, maybe. But anyway, I finished my today's coding practice with this. Thank you so much. Bye.